Okay, Assalamualaikum and hi everyone. In this video, I'm going to show a few examples on how to solve problems. The first question here, it says, show that the atomic packing factor for BCC is 0.68. Okay, so this is the formula that you should be using. The formula for APF, which is Vs over Vc. What is Vs and what is Vc? Please refer back to my notes, alright? I'm not going to explain each and every detail because something like this, Vs and Vc, I will leave it to you to dig up information, what is Vs and what is Vc. Now, that is the only way for me to get all of you reading or listening or watching my notes. Okay, so the calculation for the Vs is as shown here. So 2 here, what is 2? 2 is the number of atoms. Number of atoms, because we know for BCC, the number of atoms is 2. Okay, for BCC, the number of atoms is 2. Why 2? Again, please refer to my notes. I already explained in my notes for BCC. And then this is the formula for the volume of a sphere. Okay, 4 over 3 pi r cubed. So this is the volume of a sphere, and this is the formula for the Vs. And then for the Vc is just 4r over this formula here. And what is this actually? This is actually the A, or the age length, unit cell age length of unit cell. Okay, so Vc here is actually just A cubed, and A is the one in the bracket here. So by solving this, you will get this answer. Now it's time to substitute back all these formulas into the main formula here, Vs over Vc. So by solving this, you will get 0.68. Please try this on your own. Alright, next question is this one. If the atomic radius of aluminium is 0.143 nanometer, so this is like R for aluminium, okay, is 0.143, calculate the volume of its unit cell in cubic meters, in meter cube. Though it wants the volume of the unit cell. So this is your unit cell, okay, so it wants the volume of the unit cell for aluminium. So when you get this kind of question, make sure you understand what the question wants. So then Vc equals to 16r cubed 2 square root. Where did I get this? Again, this is this volume of the unit cell length is A cubed. So what is A? So A is, you can refer back to my notes. You know that the okay, since it's aluminium, so aluminium actually an FCC crystal structure. For FCC crystal structure, this is the volume of the unit cell. This is the formula of the volume for unit cell. You can refer back to my notes. Alright, so what you have to do is you just substitute all the values. 16 here is from here, and R is that radius of the aluminium. And then by solving this, you will get the volume of the unit cell for the aluminium. Alright, another one here is theoretical density computation for copper. Copper has an atomic radius of 0.128 nanometer and FCC crystal structure and atomic weight of 63.5 gram per mole. Compute the theoretical density and compare the answer with the measured density. Okay, here in this question, they ask you to compare with that of the measured density. So this one, the measured density from the literature is 8.94. See whether we can get almost the same answer or not. Alright, how to solve this? So since the crystal structure is FCC, the number of atoms per unit cell is 4. This is fixed. And then the atomic weight copper is also given here. And the unit cell volume also can be solved using this formula. Alright, and also the atomic radius is also given. So what you have to do is just substitute all the necessary values. N here is 4. ACU is the atomic weight, which is 63.5. Vc, you just use this formula here. and then just substitute your radius, atomic radius for the copper inside, and then Na is the Avogadro number, so you can solve the theoretical density for copper, which is in close agreement with that value of the one that we obtained from the literature. Alright, thank you.